Hello, thank you for joining me today on this presentation for Autodesk Inventor collaboration with Autodesk Revit. My name is Mark Givens. I'm a technical specialist with Autodesk for the architecture, engineering, and construction industry. As we talk about our AEC industry as a whole, we can really begin to see that there's this big, expansive world which encompasses everything from the design end through construction and into manufacturing and fabrication. There's the designers on the front end that are going through and working through things. As it gets to the contractors, then there's usually some back and forth, some redesign happening, and at the end, it's handed over to the people who are actually constructing or fabricating these elements. Now, as someone that is working in that industry, on the manufacturing and fabrication side, do you ever feel out of the loop or out of sync with what's getting designed and that whole process before it gets to you? Sometimes you're getting information that's outdated. Sometimes you're not seeing the redesigns and everything that's gone through in that process. So sometimes it's difficult to wait and get that information later on. Today, we have a global population of 7.5 billion people, and 3.5 billion of us are living in cities. So over the next 30 years, by 2050, it's predicted that 10 billion people will live on the earth, and 2/3 of those in cities. All these people are going to need communication, transportation, they'll need houses and bridges and roads. More is coming, right? More will be needed. As we plan for that inevitability of designing and building more, how do we balance that with the reality of using less? We're going to have less natural resources. There's going to be less water consumption. There's going to be less in the building process and global waste. So how do we provide that more with less? And how will our industry meet the growing demand with fewer people to do the work and those finite natural resources? So these are the questions that we're asking here at Autodesk, because we believe that along with the inevitability of more and the reality of less is the opportunity to do better. We can provide better communication. We can provide a better streamlined workflow to help us get from point A to point Z more fluidly. So how do you take advantage of this unique opportunity for us to play our part in this growing industry? How do you provide choice to your customers without increasing the time it takes to prepare an accurate quotation? How do you increase flexibility in your design process without increasing that time to manufacture? How do you manufacture increasingly complex designs, yet still be cost effective? It's no longer simply about just selling your products to the building industry. Your customers want your support to design better buildings, and they want your support to manufacture buildings that are more efficient and less wasteful to produce. One of the biggest problems that we're facing in building product manufacturers and contractors in the AEC industry is coordination and rework. Many times contractors will come back and say that the main thing that has added to their time and they're negatively impacted their labor productivity is that lack of coordination and collaboration. And oftentimes that profit margin is linked to that final payment, which is only received once the products are installed and commissioned and signed off on. So today I'd like to show you some new functionality released with Autodesk Inventor 2021 that allows us to reference a Revit project file in Autodesk Inventor and use in coordinating our design with the collaborative 3D design model. The technology behind this is known as AnyCAD, and it allows us to reference CAD files into Inventor from other CAD systems without file translation. And so this is huge. You're able to take any of these CAD file formats, bring them directly into Inventor, and begin to continue to develop your manufacturing drawings, your bill of materials, your all of the information that you need to produce in the end. And that benefit is that you can collaborate with the designers who are still using those other CAD tools without having to do heavy file conversions or go back and forth with different formats and versions of that. So let's see how this works in context of our AEC industry. The workflow that you'll see in this presentation, it all begins in Revit. So we'll start with our Revit model, and it can be shared simply as a file in many other venues, or most effectively through our BIM 360 docs. Once that's brought into Inventor, we have the manufacturing drawings being produced, the parts lists, everything begin to move forward with that. That can be synced with Inventor, referenced directly into that software, so that what you are seeing is actually the Revit model, the designer's model. You can see the architect's design intent in there, and those elements get replaced with the Inventor models that you are producing. When the manufacturing models are positioned and sized correctly, then you can see how they can be exported back again as native Revit geometry or as BIM neutral file formats that other software can bring in. But most importantly, we can see that all these, as these design changes occur, it carries through the project. So when an architect or designer makes a change in the Revit model, it can carry through to your Inventor models, and then update your manufacturing drawings and price lists and bill of materials and everything else that comes with it. And then it gets pushed back into Revit, which then completes that circle of collaboration. No more having to share files and look at and see which ones are the right ones, which ones are outdated. Everything becomes much more streamlined and fluid at that point. So let's start here in Revit. This Revit project file is pretty small by Inventor standards, but it still contains a lot of detail, and we just simply don't need that much detail. So thankfully, the designer created a view for us that's just called 3D exterior solar shading, and they filtered out a lot of the components that we don't need in this. So let's focus on the item that we're going to be working on, which is this awning that's built into the curtain wall. And as you can see, the design model of the awning is pretty simple itself. There's just enough information to define the performance and demonstrate the aesthetic of that solar shading solution. So in our imaginary scenario, it'll be our job to develop that awning design for manufacture. So let's move across into Inventor now. And before we reference the Revit model into Inventor, we're going to take a look at the awning itself. In Inventor, we've developed our awning design with all of the information we need for manufacture and installation, including the bill of materials, the drawings, installation drawings, manufacturing details, all of it. And we built this model using a technique called iCopy, which allows the model to dynamically resize. iCopy will copy the drawings along with the model to save us time when we come to prepare this project to manufacture. So we'll assume that this isn't just a one-off design, but it's a system that we can reuse across multiple projects. So we've prepared the model using the Inventor's iLogic, which allows us to configure the design. For example, change the depth or the angle of the awning, or alter the number of slats in that awning. We've also added the ability to control the detail level of that assembly. The AEC doesn't want our fully detailed manufacturing model any more than we want their fully detailed Revit model in Inventor. So once we have that ready, then it's ready to reference into the Revit project into Inventor. And we can start here with just an empty Inventor assembly file. We'll grab the Revit model and we'll go into the, Inventor, go up to the ribbon, to the Assemble tab, and place imported CAD file. And we can browse to the Revit model, and the dialog box will open. We can, we'll be presented with those views that we can select to bring in. So we'll select that 3D view that was created for us and click OK. The Revit project is then inserted into Inventor assembly file, just like any other component would be. And we want to make sure that the coordinates of the Revit project match the coordinates in Inventor. So we'll right-click and choose Place Grounded at Origin. Now, if we look over at the browser, we'll see that this inserted Revit model has a small blue arrow, and that indicates that the Revit model has been linked into the Inventor assembly using NACAD. If the Revit file is updated, the inserted Revit file will be updated in Inventor. And we'll see how that works a little bit later in this demo. So as we browse through this, we can see the different categories. We can see drill down to the elements that we're interested in. And so we're going to find those awnings in the architectural model, hide them so that we can then replace them in our manufacturing drawing. So here we are back in our Inventor assembly model. And I've kind of skipped forward in the process, but you'll see that we've already placed some of the awnings. I wanted to show you a way to place iCopy components using a pattern. So we'll start the iCopy tool again, and this time we're going to switch over to the Feature Pattern tab. The iCopy tool is looking for a pattern of points to use as an input, so we'll find one. We'll browse down to the south level 3 panels. We'll pick the top left, top right, bottom, and bottom right points. Now the difference is that each of these points has been patterned using the Revit model as a reference. The iCopy tool will place an occurrence of our panel at each point of the pattern. If we expand the dialog, we'll see that we have the option to place all 4 occurrences or select occurrences to place. And just as before, we'll click Next to choose which components we want to copy and reuse. And then we'll stick with the defaults for file naming. Okay, at this point in our design process, let's imagine that we've received a change order from the architect for the west facade. I know, crazy, right? That you would receive a design change during manufacturing process. But it happens all the time, as we know. It turns out that the position of the stud wall on the north end of the west facade needs to move, which will affect the width of the panels. But we're not too concerned because we know that our Inventor model is referencing the Revit model. So we'll flip back over to Revit here and switch to a saved view of the wall that needs to move. And the wall is selected, its position set from the end of the curtain wall. And we'll imagine that the 11-meter dimension needs to be changed to 12 meters. The model in Revit is updated, and then we save it. As soon as that model is saved in Revit, we'll see the lightning flash symbol appear in the quick access toolbar in Inventor. And that indicates that an update is available. In Inventor, we'll click on the update tool to update that referenced Revit model. Inside Inventor, our manufacturing models of the awnings will automatically update them using the coordination points that we referenced from the Revit model, which saves us time. But more importantly, it reduces the need to check and coordinate and go back and forth with our designs and those that have been reissued for approval. And of course, a change in Inventor will update everywhere, right? It updates the bill of materials, the drawings, the manufacturing information. Everything's updated, and that all reduces that time that it takes to prepare this design for manufacture. So going back and forth between that design change and the updated manufacturing drawings gets significantly decreased. Now that our model is authored, we can export this awning model to a BIM format. We can go to the Publish panel, click Export those building components, and we have the option to save this file as a Revit family, as an Autodesk Exchange file, or as a neutral BIM format, which is IFC. In this case, we're going to choose an IFC file so that our design can be linked directly into Revit using that shared coordinate system that we verified earlier. So looking through this process, you can see that using the Inventor NACAD for Revit collaboration really helps to bring that collaboration process together very smoothly. We were able to reference Revit projects into Inventor using NACAD. You would use that Revit project file to correctly size and locate our Inventor designs. We could add our connectors and do everything we need for the Revit MEP side if we have electrical or plumbing components, air components as well. We can export an IFC or a Revit family for use in Revit itself And then when the Revit project is updated, the AnyCAD associative link will update all of the documents in Inventor. Again, really streamlining that process. I'd like to leave you with this quote from one of our customers, Matt Quigley from the Conform Group. What we're focusing on now is customization. Our products are already modular, but we need to give our customers a measure of customization and to do it fairly easily without putting all of the work on our engineers. That's why we chose to move forward with Autodesk, to free up our engineers' time and win more business. So the question that I leave you with is there a way that you can begin to put the software to work for you, to free up your engineers, your staff, streamline that collaboration, and improve the workflow to produce more? Thank you.